Was there a way to just put the presentation on our, what am I trying to say here?
All right. Yeah, Tim, I'll answer that question in just a second. Let me get all right, everybody. For those of you who are watching either live or pre-recorded, welcome to the Strand Astronomers meeting for April 2023. So hard to believe it's already April. So there was a request to post just the presentation, not just the video. And yeah, we can certainly do that on the website. If you give me, it's pretty busy the next 2 days, so give me a couple of days. I will get that done so that everybody can see the materials. That's actually a good idea in general to have that. So, but yeah, we'll actually be glad to do that. So again, welcome everybody to the April meeting. Before we talk a little bit about eclipses, and I'm sorry, it's kind of hard to close the browser because it's when I'm looking at the video, the video that's streaming out, it's out of sync with time. So it's really confusing because I see myself doing something I was doing in the past. So my brain's not big enough to handle all that at once. So a couple things before we get started, a couple opportunities and coming up. Of course, we have observing this month, right? So at Hampton Plantation, and that's April 15th. So starting, right about sunset, but you come early. I think I have heard from some of the Low Country Stargazer folks that we have that may be doing a little bit of a work day before that, if anybody's interested. To work a little bit on cleaning up the other observing site. I'll let everybody know about that. In addition, Brook Green Gardens has asked us to come out on the 22nd of April during the day for Earth Day. So we'll do a little solar observing. I know I'll bring my solar scope. That's the 22nd. I think it starts at 10. Now, I think also, Denise, did you want to mention?
Yeah, sure. My school, Ocean Bay Middle, here in Carolina Forest, has a yearly Earth Day event. So I'm sure they're also looking for someone, if anyone can come with a solar scope to the school as well, that might be an option. So maybe possibly splitting us up if we can do that. I don't know if that's possible.
That's April 22nd at the same time, unfortunately.
Right.
So I'll go to Brook Green because I already committed that I would go to Brook Green. But if anybody's interested in helping at either location, and I will send out an email. I see Tim's hand going up.
Okay, Tim, is that are you in Carolina Forest?
I'm in Socrates. You're not far from me.
Right. Okay. So do you have a solar scope?
Yes, I do.
Okay. So that would be great if we had a solar scope going for that. I think our event is from 10 a.m. to 2 p.m. So I know we're advertising for it now too as well.
Okay.
We can get an email out to everybody about that.
Okay. Well, then I will probably be there with Tim then, and I'll have some stuff from NASA as well. So.
Yeah, I'll see if I can corral somebody to help me out at Brook Green. I have an H alpha scope I'll be bringing. So
right, there's always Gerald. He's usually around. No, he always comes. He was there last year, I think. So.
I think so. Yeah. I think Tim was there.
I went to Brook Green last year. Yes.
Yeah.
How early can I come, Denise, to set up?
Probably they'll be there as early as 9 a.m. setting up, I'm sure.
Okay.
Yeah, it's a pretty big it's a pretty big event at our school. We do it every year. So but yeah, I'm just looking here on our website for I know we're advertising it. But anyway, so yeah, probably as early as 9 o'clock in the morning, I'm sure. Or if you wanted to, yeah, it said, let's see. Actually, we have it listed as 11 a.m. to 2 p.m. So that's totally up to you. If you wanted to come as early as 9, you can, but you don't have to come that early. I mean, it's up to you, but that's what we have it listed as on our webpage right now.
Okay.
Okay. Thanks.
Sure. So for some spots.
Yeah. and hope for good weather. So certainly hope for good weather. The other thing I'll remind everybody is that dues are due if you haven't paid your dues. I'll also remind you, if you joined after October 1st of last year, you're already paid up for this year. So anybody watching on the video, dues are due. You can pay via the website right now. I'm sorry, the website was down for a little while. I'm not really sure what happened. It's when I logged in, it was giving me the white screen of death, which is WordPress's version of the blue screen of death for Windows. And so I had to kind of resuscitate the website. So it should all be working now. So that's kind of why it stopped getting updates for a little while. Not really sure what broke, but we think we managed to fix it. All right. Does anybody have any questions before we get started with our quick presentation here tonight? I'll take that as a no. All right, let me try to share my screen. And I thought I'd talk a little bit about solar eclipses because there were some questions. Hopefully everybody can see that. Some questions about solar eclipses. I know a couple of members on the had some questions on the email list. So these are just two pictures that I kind of like. One's kind of the sequence of an annular solar eclipse that somebody shot, and then of course one of the total solar eclipses. So let's talk eclipses. We'll talk just a little bit about eclipses in history because it's kind of interesting, and a little bit about behind eclipses, and a little bit about observing eclipses, and some of the tips and techniques. So the first one I'll talk about is the drunk astronomers. These are two Chinese astronomers. This is one of the first solar eclipses that we have data on and that we can pin down. This was like 2136 BCE over China, and they call it the drunk astronomers because eclipses were tied into astrology, and that was very, very important. So this was over 4,000 years ago, and these again, we think this is 22nd of October 2136 BCE, and the two astrologers at the time failed to predict the eclipse, and rumor has it they were drunk or something, and then they were actually beheaded because they thought that was such a significant miss. So it's just the hazards of astrology and astronomy back in the old days. So that's just kind of an interesting one. This is you can pretty much calculate once you know once you know the date, you can pretty much calculate the details of the eclipse, and this is the modern details of the eclipse. Actually, the first documented one is the Ugarit eclipse, and that was 1374 BCE, and this is actually the documentation. Anybody that reads ancient, I'm not sure if that's Sanskrit or not, but anybody that reads or maybe even maybe a little bit older, if anybody can read that, and that's there. So it's actually a documented eclipse, and it kind of went through the Middle East here, and that's the first time we had a document. So the ancient meaning, the people attached a lot of meaning to these ancient eclipses, or do eclipses in general, right? They had all kinds of different legends, like a celestial being, usually some kind of monster, attempts to destroy the sun. The sun fights with its lover, the moon, for those of you romantics, or the sun grows angry, sad, sick, or neglectful. This all came out of the book by Lippmann and Wilcox, Totality, which, if you're a big eclipse fan, it's a good book. In Norse mythology, the wolf-like giant Skoll follows the sun, hoping to devour it. In ancient Egypt, the evil god Set was thought to have leapt into the eye of the sun god Horus, which is kind of interesting. My favorite's always a heavenly dog ate the sun in ancient China, right? So, and then the Chippewa Indians actually shot flaming arrows at the sun, hoping to rekindle the flames, right? So there's all kinds of different cultural beliefs surrounding eclipses. There's a lot of memes about eclipses. This is one of my favorites. You see this meme a lot, but almost no one credits the author. The author is Katie Mack at Astro Katie, who's she's written several books. She's actually a really good astrophysicist and very nice person. But she came up with this idea about how you tell the difference between eclipses. This meme, the lunar eclipse course, is when the Earth is between the sun and the moon. Solar eclipse, when the moon is between the sun and the Earth. And apocalypse is if the sun pops in between the moon and the Earth, right? So we'd be fried. So again, I see that meme, variations of that meme a lot, but she never seems to get credit for actually starting it. So let's talk about the different types of eclipses that you can see, because a couple coming up, which is why I kind of picked this, and it's about time to start planning. Depending on where you are, there's actually a pretty narrow zone where you'll see, a full eclipse. But there's actually a pretty wide zone around it where you see a partial eclipse. And this is kind of exactly what it looks like, right? So you'll see the moon partially block the sun. You may have seen this in the 2017 eclipse, unless you were right in the path of totality, like came through South Carolina. For example, if you were in Myrtle Beach or Conway, Carolina Forest, you did not see a total eclipse. If you were down starting in Murrells Inlet and Pawleys Island, you saw a total eclipse all the way down through like Charleston. So because the shadow of the moon is basically many times broader, right? So that's why more people see the partial eclipses than the total eclipses. Kind of when you talk about the shadow, you talk about two parts of the shadow, right? We talking about the darkest part of the shadow is called the umbra, and the lesser shadow is called the penumbra. And this kind of shows you basically how that this kind of pretty good picture of it. So you see that the umbra actually focuses down to a fairly small point, right? And as that traces across the Earth, that's the people that will see totality. The penumbra are the people that won't, right? So anybody in the umbra sees the total solar eclipse. Anybody in the penumbra sees a partial eclipse. And this is kind of a really good picture of it. I actually love this picture at the bottom here. And let me see if I can get my little pen here. I love this picture because you can kind of see where the totality is. You see it kind of falls off, but then you see there's the partial. You see it just kind of falls off, completely falls off, but it doesn't, but there's still this significant shadow here. So it's actually a pretty good picture for that. So I'm sorry, was there a question? Sometimes when I get talking, I just don't pause.
I was gonna ask the question. I noticed it wasn't the shadow wasn't perfectly round. Is that because of mountains and valleys and stuff?
Yeah, I mean it's because of the clouds and everything, and yeah, the shadow's not, it won't look perfectly round, but it basically is round, but there's a lot of local topography and differences with the cloud cover and the reflections. It's a good question though. So of course, one question I always get in my classes is why don't eclipses happen every month? When there's a full moon or a new moon, right? And the reason is that there's a slight tilt, only about 5 degrees, in the moon's orbit versus the Earth's orbit around the sun. So because of that tilt, when you have a new moon or a full moon, a lot of times it's not lined up to be directly in front of the sun. It's going to be a little above or below it. And so that's why we don't get eclipses all the time, every month. It'd be cool if we got them every month, but there's this whole thing, the basic geometry of eclipses. I'm talking too fast. It's called the line of nodes, right? Whenever the line of nodes points toward the sun, they're favorable for eclipse. Because what happens is, you see that it's tilted, the moon's orbit is tilted, but what happens is it sort of precesses, so it sort of rotates around the tilt as it orbit around the Earth. So not only, you see the point is when it's right here, you see full is pointing this way, right? So if this were not changing, not precessing, then when it got around to this point, the full moon would be pointing this way still, right? But you can see how it's kind of rotating around. So in addition to rotating around the Earth, the orbit, it actually is kind of precessing and kind of rotating around. So when you kind of add all this up, it means sometimes there are seasons or times when you're going to get eclipses and other times you're not. And they're not like predictable, like, oh, it's only this time of month or, these set of months, right? There's actually something called a Saros cycle that, basically predicts when you're going to get eclipse. The other thing that's a problem with eclipses is the fact that the moon's orbit is elliptical. And that means that sometimes the moon's closer and sometimes it's farther away. This is kind of a picture of the difference between perigee and apogee. Of course, perigee is being with the closest point in its orbit, and apogee meaning it's the farthest away. So this is what they would call a supermoon, right? You see supermoon, you see a lot of hype with supermoon, but it really doesn't mean anything other than the moon's a little bit closer to us, right? But you can see it is actually bigger. So this kind of impacts what kind of eclipse you're going to see depending on where it is in its orbit when an eclipse happens. So the next one that's coming up is an annular solar eclipse. So what's an annular solar eclipse? Well, this is when the moon's near the apogee or farthest away. And when you're going to get the umbra, the dark part of the shadow. And you see what kind of happens here is you see, instead of focusing down to a point, because it's a little farther away, it focuses to a point, but then it starts to spread out a little bit because you're farther away. So that means this center part, the umbra part, it's actually called the antumbra at that point, once it crosses this focal point, will actually be what's projected on the Earth. And so there's people still out here in the umbra, they'll still see a partial. No problem there. But the folks inside the path of annularity, it's not totality, will see this. Because the moon's farther away, you won't get the same kind of show that you get with a total solar eclipse. So you're going to still see the outer ring, or the ring of fire, some people call it, of the sun. So this is what you'll see in an annular eclipse. Not that it's not spectacular. Total eclipse is better, but still, it's not the same. You won't get the same sort of effects. This is actually the next one for North America. That's actually going to be, well, about 6 months from now, in October 14th, 2023. And you see the path of annularity right here. And you see it kind of comes back down like through Oregon and goes through Texas, and then carries on into Central and South America. Now, this means for us here in Myrtle Beach, we will see a partial eclipse because we're not on the path of annularity, but we still be able to catch a partial eclipse. So if you could want to know how much, you can get these kind of graphics. By the way, a lot of these graphics come from MrEclipse.com, who's Fred Espenak at NASA, and has a lot of really great information about eclipses. If anything you want to know, you can see for us, we're right here between 40 and 50% of the sun being obscured. So about half is what we'll see here if you don't travel to the path of the annular eclipse. Of course, if you're down here in Texas, especially down here near Galveston, of course, you'll get, a complete annular eclipse, right? If you're somewhere in Ohio, you're in between 30 and 40. By the time you get up to New York, you're down here. So in between 20 and 30 again. And then, by the time you get up in the Maritimes, you're pretty much almost getting out of it. So what to expect to see during annular eclipse? Again, it's not quite as good as what you'll see during a total eclipse, but you'll see, if you're not in the path of annularity, see something like this. It's still worth doing, still worth getting out your camera, especially if you have a solar scope, you can get some good pictures. And then for the path of annularity, you'll see something like this. So it'll be considerably darker. It will grow dimmer, and it may seem a bit cooler. The temperature may drop off. You'll notice that, especially during a warm month like October, right? You'll get some animals, insects and things that will think it's night. And so they'll start behaving like they do at night. So that may mean, the bugs will start making noise and everything. So you will see a little of that. It's not as much as during a total solar eclipse, but you will see some of that. So it's still something very cool to see. this is just the phases of an annular eclipse. And we kind of talk about various timings. You can see online, you'll see various timings. And the numbers they mostly use is first contact. And that's like P1. And that means when the sun first starts getting blocked out. So when you first start seeing the moon's disk on the sun. This is a little after first contact, but at least I tried to find a decent picture. And then you'll have like second contact, or P2. And that's when you can pretty much get the entire moon shadow. You can see the entire moon shadow at that point. And then this is annularity in the middle. But then third contact is when the moon shadow contacts the other side of the sun, or reaches the other side of the sun. And then fourth contact is as it's moving off and the sun's becoming full again. So when you see the times, that's what you'll see. And you'll see things like this. And I picked San Antonio, Texas, that you can look up various locations, right? This is for the 2023 eclipse. You can see the first contact's really about 10:23. And you can see it takes basically an hour and a half before you get to annularity. But you see from there, annularity doesn't last very long. It's like, basically this is second contact, and this is the height or maximum annularity right here. And this is third contact. So you can see the whole length of it really is about 4.5 minutes of when you'll see it. And that's like most of these eclipses, they don't, solar eclipses, they don't last very long. The height doesn't. And then as it starts moving off, you can see again, you've got like another hour and a half before it completely clears. But you gotta be watching, and you got to have good weather right at the moments that you got, the height of the maximum eclipse. So that's why it's so dependent on the weather. Now, those annular solar eclipses are cool, but the total solar eclipses are really fantastic. If you've ever seen one, they're really cool. And again, this is when the moon's lined up, so the umbra comes to that sharp shadow, and you'll have this path of totality, and then around it, you'll have this area where people see partial solar eclipses. The next North American one, of course, is in 2024, April, just about a year away, actually a year and 2 days. You can see it kind of comes down here through Maine, and then you'll go through Ohio, like Cleveland area, all the way through Texas. So it's kind of cool. There's this one place in Texas right here where it's going to see both the annual eclipse and the total solar eclipse. And so you can see here in Myrtle Beach, we'll also see a partial eclipse if you don't travel for this one. Here's kind of the map of that one. And you can see where we are here in Myrtle Beach. It shows us between 70 and 75%, really about 72% of the moon will be, the sun will be obscured during the height of the eclipse. Of course, if you're up here near Cleveland or something, you're going to be in the path of totality. So if you're planning on doing that, by the way, planning on going to see it, probably many things are already sold out already. So I would definitely make your plans now. If you have relatives there, let them know you're coming to see them. That's going to be my plan for getting to see the eclipse. So the total eclipse phases, you got the same idea with the P1, P2, P3, and P4. So, you've got this partial eclipse. You got P1, and then you get to the point where P2 is when it starts that. When it blocks it completely off, and then P3 is as it starts to move off, and P4 here. So you look at the times, and I pulled a couple of them. I pulled like Cleveland, Ohio, which is where hopefully I will be, and you can see again the maximum eclipse. It's really not that long. It's like 4 minutes long. This is the maximum eclipse, but the totality is really only about 4 minutes long. And that's more than we got with the 2017 eclipse in many places. So that's not too bad. But then again, you can see a much longer period of lead in and lead out. Now, the trick is with an annular solar eclipse, and I didn't mention this, you want to be really careful because you always want to use solar protection. It never gets dark enough you can look at it with your naked eye. It's not true with the total eclipse. Once you go into a total eclipse, you can look at it with the naked eye or binoculars. In fact, you get really good views. As long as in the partial phases, you need to use protection. It's so important. And, definitely pay attention to the time. Definitely pay attention to the time. So some fun eclipse facts. The maximum totality possible is 7.5 minutes. So the best eclipse you're ever going to get is 7.5 minutes. Those are rare though. 4 to 5 is usually what we see most, right? The moon shadow, when you kind of look at how it works, the moon shadow is actually moving about 1,700 kilometers per hour. So it's over 1,000 miles an hour. So it's supersonic speed. It's moving more than Mach 1. And we'll see how that kind of affects you later on in a slide or two, right? So it's actually moving very, very quick. Every place on Earth, no matter where you are, will see a total solar eclipse about once every 400 years. And solar eclipses occur more frequently than lunar eclipses. And that surprises a lot of people. A lot of people think, well, we see a lot more lunar eclipses, but solar eclipses are actually more frequent, by about 5 to 3, so a little more than half. You're like, well, why don't we see more solar eclipses? Well, again, the path of totality is small. It doesn't necessarily go that far, and many of them occur over the ocean. But you can look over in the like Mr. Eclipse to see the upcoming solar eclipses and see where they all go over the next few years. Of course, again, just living here in North America, we're not getting that too many. There has to be at least 2 solar eclipses every year. There just has to be. There can be more, but there has to be at least 2, just by the mathematics of the line of nodes and everything. There can be 2 solar eclipses in back-to-back months with a total lunar eclipse in between. So that can happen. That triple eclipse can occur twice during an eclipse year, and it did in 1935. That happened. So that was a good eclipse year, and then that'll happen again in 2160. So don't hold your breath or don't cancel your plans for next week. Because you got a little bit of time before that happens again. And the maximum you can get in a year is 7 eclipses. You can get 4 solar and 3 lunar. Had that in 1982, and again, we won't get it till 2485. So, will we always have total solar eclipses? Well, the answer is no, not really. So the diameter of the sun's about, 1.4 million kilometers or 870,000 miles. I don't know what that is in bananas. I know everybody uses bananas for measurements now. That's a lot of bananas. So that's mega bananas. So that basically gives you a annular or an angular size of the sun, 32.7 to 31.6. Again, because our orbit is elliptical as well, right? So the diameter of the moon's, basically a little over 2,100 miles or almost 3,500 kilometers. So that gives you this angular size of 33.5 to 29.4. But the moon's receding from the Earth by about 3.8 centimeters per year. So that means when it's drifted another 12,500 miles away, it will always be smaller than the sun. So, approximately 500 million years, you won't get total eclipses anymore. So we're living in a pretty good time because we get to see that. Notice because of the moon's drift out, Earth's day also lengthens by about that much time. So that's what, 16 ten thousandths of a second every century. So we do slow down. Our orbit will slow down. So another 500 million years, the Earth's day will be considerably longer than our current 24 hours. Okay, so when you're talking about, let's talk about observing eclipses. This is the fun part. Most important thing, safety first. Never look at the sun through telescope binoculars. You can get permanent damage or blindness in seconds. And it is permanent. It can be very permanent and nothing can be done. So this includes looking through a camera viewfinder, right? I mean, a lot of people think I'll be okay if I just look through the camera viewfinder. Please don't. Never look directly at any part of a solar eclipse except during complete totality directly. So don't do that. Also, don't use homemade filters. There's lots of recipes on the internet for homemade filters. Please do not use these. Of course, you can't believe everything you see on the internet, and that's true with your eyes too. Buying a pair of eclipse glasses, or if you have a telescope or binoculars, a proper solar filter, it's worth it to avoid any damage to your eyes. The other thing is, you see a lot of these things out here, these eyepiece filters, these sun filters that screw into the eyepieces. See them most from these old department store telescopes that they sold years ago. These are very dangerous. In fact, so much so that every time we ran across them in our telescope clinics, we would take a hammer and we would smash them, because they are just unsafe. Why are they unsafe? Your telescope actually focuses a lot of energy from the sun, concentrates it. And what happens is it concentrates it on these filters. And then it's maybe, I don't know if you can see it very clearly, but this is cracked and there's a piece missing. They will crack. And then when it happens and you're looking at the sun, you get full blast concentrated sun. So again, if you have one of these, please take a hammer to it and get rid of it. So safety is the most important thing. You can get CE compliant or ISO compliant eclipse glasses. A lot of places give them away too during when eclipses are close, like probably before 2024, they can. You can actually buy plastic ones. I've got a set of plastic ones that work pretty well. And they work great and they're perfectly safe to use. Of course, yeah.
You got to buy these things on the internet. You got to pay attention, because in 2017, 4 skulls bought about 1,000 pair of these, and they were fake.
Yeah, you do. You do have to be careful about that. So I generally recommend going to
Yep.
thanks for bringing that up, Tim, because you want to go to reliable vendors. Unfortunately, not that Amazon itself is unreliable, but because different stores, so many different individuals and companies list on Amazon, you do have to be careful. I would recommend going to one of the astronomy companies like OPT, Astronomics, High Point Scientific, and of course NASA also was giving away glasses. Those are all good sources. So thanks for mentioning that, Tim. Of course, you can use a proper solar filter, right? And proper solar filter is one that goes on the end, the objective, the large part of the telescope. Those are safe to use because you're not concentrating the light. So you definitely want to, if you have one of those, you definitely want to use one of those. And again, you can make your own, you can do it safely, but you need to be kind of careful. But most white light filters do not cost that much, and it's worth getting one that's a proper filter. Another thing some people do is they project the sun using the telescope, and they don't use a filter in this case, but they project it onto a card or onto the ground. You can do this. You want to make sure that your eyepiece and your diagonal can take the excess heat, but it won't hurt your eyes. It may create a problem with the diagonal. If it's got glue in it or something, it may melt, but it's still safe to do this as long as you don't look anywhere in it. He's actually kind of projecting it out like this. Most people turn it, so most people will turn this eyepiece or the diagonal so it points downward and put the paper on the ground, because that way there's no chance of anybody like getting in the beam, right? So it's a good safety tip, right? One thing you can also do is you can make a pinhole camera, and these are pretty cool actually. You can take like a little card, you can put like a very small hole in it, and then you can actually hold it up to the sun and it will project on the ground and show you a picture of the eclipse. And it works very, very well to make these pinhole cards. Again, you don't want to stare at the eclipse through naked eye. This is, again, the good thing about these, you can make these on a budget, right? It doesn't cost much, and I mean, basically poke a hole on a piece of cardboard, right? Eclipses are weird, and it's actually a good weird. It's really interesting if you've never seen one. It's very weird. As the sun gets obscured, the light starts to change, and you think, well, yeah, you get less light, but it's not just that. It's something else. It's darker, but it's clearer. it's one of the things I find hardest to describe. It's not like you may think ordinarily when you think darker, you think like twilight, dusk, dawn, and all that kind of thing. It doesn't work like that. Even though there's less light, it's clearer. Everything is sharper. Shadows are sharper. Everything is sharper. It's the same kind of phenomena you see like if you go to like when you get sunlight, or if you look at space missions, you look at stuff that's in where there's no atmosphere, right? Everything looks really super sharp, right? Sort of the same phenomena, different cause, but it looks like that. It's very hard to describe, but shadows become very sharp and everything seems to sharpen up. It's one of the weird things that happens that you can look for as you're waiting for the totality, right? And you can actually really notice it. There'll be a couple of things we'll talk about that you can kind of notice. And the one thing is we'll talk about a bunch of things you can notice, and there's so much that you can't really get it all in one eclipse, right? The shadows, again, will become very sharp and very contrasty. Even though the light's dropping, the shadows become very distinct. And it's, again, it's very strange. I was looking at my solar scope. I had my solar scope set up during the last one, and you can just check out how sharp the shadows are becoming. And it looks really weird. The wind picks up and the air cools, and you hear the animals and insects, especially here in the Carolinas. You hear all the night insects start up. And you can just feel that. It's just part of the weird things, right? The sky starts getting this deeper dark blue. It doesn't get black, it gets like this deeper dark blue. So remember to look up around the sky, not just focus on the sun, but look up around the sky, and you'll see it gets this deep dark blue. So you'll start thinking to yourself, wow, this is getting weird. And this is really cool. One thing you can also look at, and this is one of the coolest things, is if you have trees, and this is the Carolinas, there's lots of trees. You'll notice if you look wherever the sun's shining through all the leaves, they're acting like little pinhole cameras. So what you'll see is all these little crescents that show you how the sun or the moon is obscuring the sun. So it kind of acts like a pinhole camera. And you'll see this. So it's really cool. Again, during the partial phases, like go look under a tree or where the sun's shining through a tree, and you'll see a whole bunch of them. Depending on how tight your tree is, and pine trees are really good at this, you'll get much clearer images, right? You may get a whole bunch of little, crescents down on your sidewalk.
I got a comment to make.
Sure.
Don't look down at the trees. Also look at the trees. If you walk around and find the right spot, each leaf will have the solar eclipse on it.
Awesome. Yeah.
Yeah, a lady up in Pittsburgh took a picture of a tree with all those solar eclipse on all the leaves, and she won first prize.
Yeah. So these are a lot of the little things people don't think of when they look at the eclipse. There's so much to kind of look at. Now what you get to is when you see the whole lunar disk, there's this thing called the diamond ring. And basically that's when you have like this last little bit of sunlight shining through, and it kind of looks like a diamond ring, right? You definitely still should have your glasses on here. You need to wait until it gets to totality. And even that little bit, you go, oh, that's not much. You would be surprised how bright it actually is. And it will hurt if you look at it. So then you'll see the diamond ring. And and then there's this other thing called Bailey's beads. And that's basically right here. You'll see like a couple of little dots. You see little bright dots. And again, you still got to have your glasses on here. But you can kind of see this goes, and then you get to a total eclipse. And they're very weird, right? So as totality gets close, the sun looks like it's shrinking. Again, it's hard to describe, but it looks like the sun is shrinking. Again, that's one of those optical illusions for our eyes. Again, one of the things is if you think to look around, the east horizon, as totality gets close, the east horizon, if you look at east, it will be light. The west will be dark. And the north and south, where the partial eclipses are, will be orange. So you get different colors in different parts of the horizon. All right. Again, it's one of those things that a lot of people don't think to look around, but if you do that, you'll get that. And then right at totality, and this is actually one of the most interesting things, is everything happens together simultaneously. It's some people think it's like a really slow process, and it is, because it takes so long for the sun to get covered up, and it's actually like a slow process. But then everything happens at once, all at once, and it's almost a little overwhelming. What happens is you see the shadows that I talked about becoming sharper and sharper, right? Because the sun's going down to a point source, and it becomes very intense. Then it goes, vanishes. At that second, the moon's shadow will spring out of the west and sweep over you. But remember, it's going supersonic speed. It's going like Mach 1.5. So it's fast. It's not like, ooh, dark. It's like, whew. The sky will turn black. The stars and the planets pop out. And if you think to look around, the horizon will be orange all the way around, 360 degrees. And again, all this happens at once. And so a lot of times you can only look for certain things happening. And then next time you have to look for something else. It's very weird. So during the totality, that's when it's safe to take off your glasses and look at the sun. You'll see the corona. The corona is always there. It's one of the hottest parts of it's the hottest outer layer of the sun, running about 2 million degrees, but it's very, very thin. And ordinarily you can't see it because the sun is so bright. Now, the important thing is to remember, you got to have protection before it ends. Don't wait too long. As soon as you see that diamond ring where a little bit of the sun starts pointing out, you should have your glasses on. So of course the corona is this outer layer, right? Above what we call the photosphere. That's what we see. That's all the light we get on Earth comes from the photosphere. And then there's this chromosphere on top of it. That's sort of like the sun's atmosphere. It's a much thinner layer that's mostly hydrogen alpha. That's what you look at in H alpha scopes. And then you have the corona up here. Again, much hotter than the surface of the sun, and very extended, but very, very thin. Of course, when the diamond ring appears, you need to have those glasses on, right? It's so tempting to keep looking at it because it's pretty, but you don't want to be looking at it without glasses. So just a few tips. You need to plan ahead, where you're going to stay, what you're going to do, right? Because basically everything kind of fills up and traffic backs up. So you got to get to where you're going to go early. You need to be ready to go even if cloudy. Like when we had the 2017 eclipse, but the time P1 it started happening, when it first started happening, we had like typhoon condition 3 here with thunderstorms, and then all of a sudden it cleared, so you got to be ready to go. Remember, totality doesn't last very long. It's only a couple of minutes. So you kind of got to decide what you will look to see. Some of the cool effects, kind of think about what you want to do. It pays to think about that. If you're going to take pictures or something, great, but be careful not to get lost. Again, it's only a couple of minutes. And if you start you try to get your equipment tested first, but if you're having a problem, don't get over focused on the problem so that you spend that entire time looking at your equipment and not looking at the clips and enjoying it. You don't want to miss it. I had a problem with my camera. I was going to take some pictures. I had a problem and I literally just took it and threw it in my chair, right? Because I had told myself in advance, if I have a problem, I don't want to miss the totality. So if I have a problem, I got to ditch the camera. So I highly recommend that. The other thing is, got to be careful. You might get hooked on eclipses. I have a friend who lives in Quebec, and he takes a lot of aurora pictures. He's actually a really good photographer, and one of his hobbies is photographing eclipses. And he's been all over the world to photograph eclipses. His name's Michel Tournay. One of his best trips, or one of his most interesting trips, is he took a nuclear icebreaker from Russia to the North Pole to see an eclipse, and actually went out there. He's been to Easter Island. He's been to Africa several times. So he basically goes, and each time he looks for something different, different part of the eclipse, and tries to take pictures. But that's what he does for vacation. So be careful, you might get hooked on it. He also went to Egypt as well. And that's all I pretty much had for tonight. I thought we'd talk a little bit about that since there were some questions in our group. Does anybody have any questions or any comments?
Yeah, some of the science that's done during these like eclipses, I know like there's a lot of citizen science projects out there. So we see the corona, and I could probably Google this. There's probably how much science is being done during that time versus any other time of the year, just about
Well,
that.
quite a bit. I didn't actually put inside. I've got a few slides I can send you on the science that's done. There's quite a bit that's done because, you want to catch it when it happens. One thing is if the totality happens to go over a major observatory, they of course take advantage of it because, you can't take one of these big 8-meter telescopes and can't move it to the eclipse. You have to have the eclipse. You have to take advantage when it comes over you. So basically, that's true for any kind of scientific instruments. But there is a lot of stuff that goes on. There is citizen science that happens. There's also a lot of professional science. One thing that they do a lot of research on, just as an example, is cosmic rays. And how much, and basically some of the reactions caused by cosmic rays, how much of it are caused by the sun, how much of it are not, right? So they actually, when the sun gets blocked out, they can actually do some studies to see what's going on. So there's all kinds of different phenomena that you can study by that. And they also look at, and a lot of times it involves citizen science observations as well, because that's what you have. Different radio, there's some radio stuff that's done that they look at in terms of radio propagation and everything, because you get kind of a good example. You get a good chance to study that because all of a sudden the sun gets blocked off, where it maybe it's resulting in a bunch of atmospheric conditions that affect radio signals. All of a sudden it gets blocked off for a little bit. It's like somebody turning it off for a little bit and turning it back on. It's a great way to study the exact effects. So there's actually quite a bit of science that can be done. Again, a lot of it is citizen science, just because you have to go where the eclipse is. You can't bring the eclipse to the science. Yeah.
Of course, one of the most important sciences was when they confirmed Einstein's theories.
Sure. When Arthur Eddington, confirmed, relativity, general relativity, right? Which if you really are, really into it, you can again measure with the positions of the stars near the sun, and you can actually see they're bent out because the light is bending coming around the sun. And that's one of the really cool things.
Something else I was just thinking, you mentioned like the drunken astronomers and the fact that the people were like beheaded and things like that during that time period. I wonder if there's any kind of like throughout history, if you look at any kind of, not that they're associated at all, let's face it, but like natural disaster associated with eclipses or anything like that, that would be interesting. But then it would bring like a lot more folklore to it all, I guess, huh?
There's probably somebody out there, has done some of that. You can always correlate things with, you can correlate two things together because correlation is not causation, but I'm sure someone's correlated that. I actually don't know of that. I didn't research that when I was doing so much research for the 2017 eclipse.
And I guess there's like, there's a doctrine, like I try to tell students about that, like that they couldn't predict eclipses and things like that there was like a religious kind of thing also associated with that by the church, I guess you would be like, those people were beheaded because they didn't know that the eclipse was happening, right? So
yeah. So many cultures had pretty good astronomical observations because it was very important to understand, like, what you had in terms of like growing seasons and things like that. And many of them had actually some pretty good predictive powers for that. But of course, if you missed it, because they were considered to be such, portentous events, right? You could get in a lot of trouble, right? The ultimate fail. So that probably happened in more cultures than certainly I documented, right? Because astrology for a long time was part and parcel with astronomy, and it was considered to be, something very important in terms of, predicting things, or, or basically like you'd be portentous of certain events, right? So you wanted to know when those were happening.
One of the funniest examples is if you can get hold of the old Bing Crosby movie, Connecticut Yankee and King Arthur's Court. There's a really good eclipse sequence in there and how the people reacted. So if you can get hold of that copy somewhere, that I always showed that to my classes, that segment.
Yeah, and of course the book is good too. So you know, Mark Twain was always good about writing that kind of stuff. So yeah, you know, because it was pretty spectacular. It is pretty spectacular. It is pretty spectacular. There's something, you know, you can read about it, but when you actually see it, it's pretty cool. It's strange, probably because it's so strange. It just feels strange when it's happening. It's very hard to describe, but it's just a kind of a weird experience. But I can see how people get hooked on it and want to keep going to see them. I'm not going to be traveling the world to see eclipses, but you know, I can see how you get there. So.
And I know they've started advertising for this one now. The one in April next year. So, and I think they're looking for, I guess, undergraduates, right, Ian, for like eclipse ambassadors and things like that.
I think so. Yeah, NASA's doing the program where they'll train you up and you can talk about eclipse science and, you know, basically a little bit about eclipses and try to help everybody out. So I know a lot of the solar system ambassadors also talk about that.
Right. Come January, probably next year, we'll probably end up, you'll get lots of requests for events for eclipses probably, and probably also in the winter of this year, I bet.
So probably, yeah. So probably starting the school year in the fall, probably they'll start rolling in. So, but yeah, there's quite a bit. All right. Well, so I want to thank everybody that's watching the video. I'm going to cut off the video right now. We'll do our we'll continue our meeting. But thanks everybody.